Today we'll be discussing about the continuity of the function with another definition because this definition is switch for the another kind of the equations. So the last time we had the definition that limit of fx at the point x tending to a is equal to f of a. So for there the value of x are 2, 3, 4, and it keeps on continuing. Just what value of x? What if the value of x is lying between two numbers, or what if the value of x is fluctuating? So for this kind we're gonna make another definition, that is limit of fx at x tending to a minus equals to limit of fx x tending to a plus is equal to f of a. Then we say that the function is continuous. Now keep in mind one thing here in this definition, this one satisfies this one of the previous question. Now this one is said to be the left hand limit, and this one is said to be the right hand limit of the function. So there will be the expansion of this one, so we expand this one like this: limit of fx x tending to a minus is equal to limit of fx f a minus h, where h is tending to 0. So here we are replacing the value of x by a minus h, and the value of h is tending to 0. Here the h tends to 0. So x is being replaced by a minus h. I'll explain to you what is the meaning of h now. The next thing is f of x tending to a plus. This one can be represented by this way: f a plus h and h tending to 0. So x is being replaced by a minus h here. Here is a plus h, and this one is said to be the right hand limit, and this one is the left hand limit. What is h here? H is a very small number, very close to 0, so it's tending to 0 here. Now what is a minus and a plus here? Let's draw a number line and fix a point here. Let's take this number to be a. So because we're all dealing in a minus means the numbers that are coming to a from the left hand side, so we give the name left hand limit a. So this will be the natural numbers, and a lot of numbers lie between this one, and a is very small number. A minus is very small number. A lot of numbers between this one and this one. So we have thousands of numbers between these 2 points. For example, if I take a to be equal to 2, a minus will be equal to 1, because since it is coming from the left hand side, we have 1.9999, or else now 1.9998, and the number continues like that. Similarly, a plus means the number coming from the right hand direction to this a, so a plus will be equal, it has to be a little bit more than 2, so 2.0001, 2.0002, whatever. So we don't have to be concerned about this kind of numbers, but this is only a kind of number that a minus and a plus holds. So if we have these two conditions being satisfied, and if this one is equal to f of a, that is from before, then we can say that the function is continuous. So if you know this definition clearly, we can proceed with the next question. We will be doing question number 7, so which says that find all the points of discontinuity of f where f is defined by this one. You need to keep in one thing in mind, that this kind of functions are continuous everywhere except at some of the given points. So we need to check whether this function is continuous at minus 3 and 3. Oh sorry, discontinuous at minus 3 and 3, because we have 2 points here, minus 3 and 3, here also 3. So we need to check at 2 points. Now the function is defined here based on the numbers minus 3 and 3. We will be checking this one after the other. So we'll check the first number at minus 3, whether the function is continuous or no, at the point x equals to minus 3. Now listen here, we have minus 3. This minus 3 can be defined as minus 3 or less than minus 3. This one can be defined like this in two ways. So less than means left hand limit. The value of x is less than minus 3, so this will hold the left hand limit. So this function will hold the left hand limit for the value, or for the value at point x equals to minus 3. So at x equals to minus 3, we have left hand limit. This definitions, you know, we have limit of, you need to know how to write this one, x minus 3. You need to write this minus, because these are the numbers coming from the left hand side of minus 3, is equal to limit of the value of fx will be this one, because this one is left hand limit, x plus 3, x is minus 3 minus, now the definition we have introduced a minus this one, so we'll be introducing this one. This a minus h is a is this number itself, so this is equal to limit of, now since you'll be replacing the value of x by minus 3 minus h, a minus h, because your a is minus 3 here, plus 3, mind you here h will be tending to 0. You can write replacing x equals to minus 3 minus h, that means a minus h on the previous definition. Okay, so this is equal to limit of, don't put the value of h now because we have to do something here. This minus, you can take common here, minus common, plus 3. We know that the value of the modulus will give us a positive number, so we can have 3 plus h plus 3. Now you can replace the value of h by 0, so this is 3 plus 0 plus 3 is equal to 6. Okay, left hand limit we found to be 6. We'll check for the right hand limit now. Right hand limit, we have limit of fx, so x tending to minus 3. This is your right hand limit, minus 3 plus is equal to limit of, now we need to check which one is your right hand limit. Now okay, what is minus 3 here? This minus 3, x is greater than minus 3, so you got to take this function, because this one is for the right hand limit since x is greater than minus 3. So we'll be choosing minus 2x. Same thing. Now replace x by 0 here, so minus 2, x will be have to replace by a plus h. Reason is replacing x equals to minus 3 plus h, that's equal to, or else a plus h replacing it. So multiply this one, minus, oh sorry, minus in the minus is plus 6 minus 2h. Now you can put the value of h at 0, so 6 minus 2 into 0, that is equal to 6. Also f at the point minus 3 is equal to, now equals to, x equals to minus 3 here, so at this point we need to check what is the value. So minus 3 plus 3 minus 3 modulus is 3, 6. Now you can see 6, 6 and 6, so we can have the final thing. Since left hand limit is equal to right hand limit is equal to f of minus 3, because we are checking at the point minus 3. Therefore fx is continuous at x equals to minus 3. Now we're done with minus 3. The next point is we have 3. Now look back to the question itself. Minus 3 we have done, and we have to do for this 3. Point number 3. Okay, now this is done. Okay, now at x equals to 3, same thing, left hand limit is equal to limit of x tending to 3, because at the point 3 left hand will be minus fx. Okay, so limit of x tending to 3 minus, you need to check which one is the function, because we have two functions left here, this one and this one. We're checking at the point 3. So if that is 3, the number less than 3 is this one, so you need to make use of this function. So this will be minus 2 of x. Do not get confused, try to know it by looking to this video again and again. Limit of, now x will be replaced by h tending to 0 minus 2, x will be replaced by 3 minus h, just like previously, x is equal to 3 minus h, replacing x by 3 minus h. Okay, so limit of h tending to 0, multiply this inside, minus 6 plus 2h, now replace the value of h by 0, so minus 6 plus 2 into 0 is equal to minus 6. Take care of this answer. Now the right hand limit will be the same thing, limit of x at what point? 3. Right hand is plus here, don't forget this plus here because it's gonna make a difference. A limit of, okay, so x tending to 3 plus, now right hand limit means greater than the point 3, so this one is greater than 3, so you got to use this function. Okay, that is 6x plus 2. Okay, let's continue. Now x will be replaced by h tending to 0, so this will be 6 into 3 plus h, because this is the right hand limit 2. You can write here x is equal to 3 plus h, replacing. Okay, replacing this equal to, now multiply that 6 inside, 6 3s are 18 plus 6h plus 2, that is equal to limit of h tending to 0, 18 plus 2 is 20 plus 6h, this equal to, now replace the value of h by 0, 20. Now see here, this left hand limit is minus 6, your right hand limit is 20. They are not equal. So what we can say here is, since left hand limit is not equal to right hand limit, therefore fx is not continuous at x equals to 3. That is your answer. So we found at x equals to minus 3 this is continuous, and at x equals to 3 this one is discontinuous, or we can say at x equals to 3 this one is not continuous.